And we're live. Welcome back. We're with Matteo Casu. He is a semantic engineer at Semantic Partners, and he has over 15 years of experience working in academia and industry, uh, working with software, graph data structures, and semantic technologies. Today, he's going to give us a presentation on a graph frag proof of concept around the human resource domain.
Thank you, Joaquin. Thank you very much, and good evening, everyone. I think I should actually thank the previous speaker because I think that that particular speech tallies very well with some of the concepts that we will be using now. And so I am a consultant at Semantic Partners. I joined last winter. Semantic Partners is a small consultancy in the UK and Europe mostly, but also with a presence in the US. We have a number of clients in different sectors: supply chain, healthcare, automotive, and we specialize in semantics, in different aspects of semantics. Most of us, especially myself, I would say, we come from a background in symbolic AI and the semantic web stack. So referring to the previous presentation, I would say our expertise is in the type of knowledge graphs that come under the flavor of RDF. But we also like property graph models, and we like to keep an open mind on the definition of semantics and on all the applications that you can do with semantics. And this is particularly relevant to this piece because we embarked in a sort of self-learning exercise. At the beginning of this year, we wanted to understand how LLMs and knowledge graphs could interact in the best way possible. So I'm going to run through the whys and the hows to give the context, then the setup. Then we will see the approach in action in our particular use case, and then we will discuss what have we learned. So just a definition of RAG, even if this particular audience is well selected, so most of the people will know better than me, but just to share a common definition, by retrieval augmented generation, we mean an architectural pattern for LLM applications, where before answering, the application, the orchestrator, retrieves relevant knowledge from a knowledge base, which can be structured or unstructured, and by that I mean structured knowledge bases such as databases, which could be graph databases in our case, or APIs even, or unstructured, like a set of PDF documents, for example. And before answering, it adds the relevant information found from this knowledge base to the LLM input, which most of the time is our prompt. So we see it in Semantic Partners and in this particular proof of concept that we've done, as an exercise in good old information retrieval, augmented with semantics. For example, to do semantic query expansion on the user's query, and we will see how it is relevant in a moment. So the context is that, as we have seen also in the previous presentations, there is an incredible amount of literature regarding the use of LLMs together with knowledge graphs. But as we have just said, there is no common shared definition of knowledge graphs because most of the time, if you go through LinkedIn and Medium nowadays, most of the time people by knowledge graph will present their use cases using Neo4j, for example, which is probably one of the biggest vendors in the property graph model space. So that's one nuance of knowledge graph. We wanted to present something similar using an RDF triple store, which is the kind of knowledge graph that we are more expert on, and that we most of the time use with our clients. Another peculiarity of the literature that you will find nowadays around is that many times people will use ChatGPT or some OpenAI service, which means that it's a third-party service which you have to pay for and send your data across, which is not necessarily something that you can do all the time. And the third component is that quite invariably, they tend to use Python frameworks like LangChain or LlamaIndex for the orchestration layer of the application. And we will actually use LangChain for our example. So what did we do in practice? I said we did this exercise of self-learning to understand what patterns we could identify in using these approaches and these technologies, and how to propose them to our clients in a sort of informed opinion way. So we did a couple of blog posts in collaboration with Ontotext. You can find them online. They've been published both on Ontotext website and on the Semantic Partners website. The first one is more technical, and it talks about a RAG retriever for a RDF triple store, GraphDB in this case, but it could be any triple store with a Sparkle query engine interface. And the second one is more business oriented and presents the use case that I'm going to talk about today, which is matching skills and candidates with GraphRag. We wanted to show the approach, matching skills and candidates, under simple sort of laboratory, if you like, conditions. So using small models, offline models, and our hope was to, as I said, it was a self-learning exercise, but also our hope is to evangelize and democratize using GraphRag with RDF graph databases. And also, in general, for us, it's a very good playground for semantic information retrieval. So to do information retrieval, not only in the traditional sense, but also using semantics, and also being open to LLMs and vector search, which are very connected to it. So what is that we want to do exactly? Do we want to use AI to hire people? That's probably what the title seems to imply at first glance. But actually, no, we don't want people being hired by AI. We also don't want the opposite. We don't want to hire AI for our own things, in the sense that we are not going towards, we're not very much interested in any kind of monolithic framework where you try to access general artificial intelligence, or at least this is not what we have in mind at the moment. What we have in mind, rather, is to see these approaches as a sort of Swiss Army knife that you can have, and that you can plug together for particular use cases, for concrete use cases. So, for example, in this case, if we had a way to use LLMs and knowledge graphs together to let skills be matched to projects, for internal projects or open job descriptions, for example, this could be one of the many ways in which a human, given a dashboard and a number of services and user interfaces, could assess and select and refine and research the task together with this technology. So the idea here is to have is to try and identify small components that can be plugged together, which in our case it would be useful for our clients, of course, or internally at Semantic Partners. So just to finish the introduction, one important thing to mention is that there are different ways to interpret the phrase GraphRag. Obviously, Microsoft has just come out with their own interpretation of the terminology GraphRag, and they made it a commercial mark in a sense. And that's about extracting a graph from text and then use that graph for doing GraphRag. Now, this is not exactly what we are doing here. The second meaning of GraphRag can be to do query generation over a graph. So you have a natural interface, a natural language query or question. You want to generate a technical query, say a SQL query or Sparkle query, to interrogate your knowledge base, which could be a database, a graph database. And this is also not what we are doing here. The third possible interpretation of GraphRag is to treat nodes and edges of the graph like RAG documents. So you embed them, you index them in a vector search index, and then you, so to speak, talk to your graph. So you ask questions, you retrieve facts from the graph describing the answers to your questions, and by doing that, you let the LLM describe the findings, and you can have a conversation about the data in your graph. The fourth option is to combine, talk to your graph, so we keep that, but we combine it with unstructured documents RAG, which is a more traditional approach to RAG, whereby you index documents like PDFs or docx documents, and then you use a RAG retriever to retrieve chunks of them, provide them to the LLM, and get answers. So this fourth combination is what we are using here. So our setup is to have a bunch of anonymized CVs. We vector index them. You can use something like Chroma or your favorite vector search indexer, vector database. And then you have a knowledge graph. In our case, we internally at Semantic Partners, we have a knowledge graph representing our clients, the products that they sell, our partners and their products, and the features of these products, and the skills associated to these products. And so it was an interesting exercise to see if we could, rather than just query the knowledge graph with a structured query language like Sparkle, or like you would do in the traditional database world with SQL, it was interesting for us to communicate with it with an LLM. And then you need a retriever for each of them. So one for the documents and one for the graph. And as orchestrator library, we use LangChain. And then we want a server, easy to use, easy to install, serving small, offline, and free LLM models. And we chose the popular Olama for that. So the idea of RAG, even in this case, is extremely simple. And we have a toy example here, so it will be even simpler than other approaches that you might find online. But it's going to be on an RDF graph. So we have the prompt. We want the LLM to find the best candidates for this job opening. And by the way, it doesn't have to be a job opening. For example, in our case, internally, we are trying to use it as a way to match our internal people to a project description. So you might have a project description, you might have a pre-sale document, for example, that you are creating with your own prospective client. And you might want to see if you have the right people and the right tools to do a bid, even to generate a document for a bid, obviously in concordance, together with a human in the loop. So we have this prompt: find the best candidates for this job opening or project description. You are given chunks of text from candidates' resumes, and we said that we have them in the search index. You're also given facts about the job sector. It could be the job sector, or it could be the market, or any other domain you have in your knowledge graph. Tell me which candidates are the best fit using the facts, so the triples in our case, and the chunks from the documents. Obviously, I made this prompt as simple as possible to fit on the slide, but you can get creative with prompt engineering. And when you do this for real, of course, you will have to adapt to your particular case, your particular model, etc., to get the best results. So the architecture, again, is quite standard and quite simple. We have a document RAG on the top left. We have a graph RAG on the top right, and we combine them together, as the prompt here suggests. We are going to fill these variables, so to speak, with the results coming from each. So the filler is given as such. So the job opening or project description, in the other use case that I presented, is given. You have it. For example, we used in our exercise our own common job description for Semantic Partners. If it's too long, you might want to summarize it using the LLM. And by the way, LLMs are particularly good at summarizing things because they are good at exploring the semantic vector space of things. They are less good at reasoning, as we know, but they are very good at summarizing things. The docs chunks are going to be retrieved by the docs retriever, and the facts, the triples, are going to be retrieved by the graph retriever that we implemented because it's not in LangChain. So GraphDB has something called the similarity plugin, by the way, and that's what we used to vector index the triples. And it's extremely simple. One of the reasons we chose that is not only because we are partners of Ontotext, obviously, but also because it's a very simple case where you can have the knowledge graph as it is, and by a couple of clicks on the interface, you can embed the descriptions of each node and each relationship in a vector index. And then it's very easy to interrogate it. So we used that. So imagine that in the prompt, we have find the best candidates for this job opening, and then the job opening goes something like, we need an expert in semantic technologies and blah, blah, blah. Perhaps with we would mention some products, some particular field, etc. Now, a common LLM will not know all the intricacies of our own sector. In our case, it's semantics itself, but in the case of automotive, it could be, I don't know, the last model of a certain car or else. So imagine you have this up-to-date and curated information in the graph. You provide the prompt to the vector search of the graph itself, in this case. So you can send to the similarity plugin of GraphDB your prompt summarized if needed. And GraphDB will return the most relevant nodes and relationships. And then by using some further processing that I'm going to show in a moment, you can have your set of triples. In a similar way, you retrieve the most relevant chunks of text from the vector store where you have indexed, in this case, the CVs, the PDFs, but it could be other documentation that you have or that your organization have. And then, again, you fill back all of these in the prompt. So one real example of what our chunks looked like, given the prompt, which in our case was the job description or a project description, we get back from the vector search retriever some chunks. You might have one chunk from one document and 2 or 3 chunks from another document because they are ordered by relevance, of course. And then you can aggregate them by the file name or the person name if it's not anonymized. And you keep them. You can select, say, the first 10, the first 20. This very much depends on the capability of the model that you have and the requirements of your particular use case. These are all parameters that you have to adjust for. The second bit of the triples, as I mentioned, you can send the prompt to GraphDB. You receive back the most relevant nodes or properties from the graph, nodes, properties, or relationships. Anything goes if it has some textual description that has been embedded. In this case, we take the first 5, we could take the first 10, and then for each of them, we select the triples around each entity that we get back because we want some context for each of these entities. So for example, if I get back GraphDB as a relevant entity to consider from GraphDB itself, sorry for the pun, but obviously GraphDB, we are using it as a database, but it's also present as an entry in the dataset itself. So GraphDB is a relevant entity. I want, say, 20, 30, 50 triples about GraphDB. What are its features? What kind of product it has? What vendor it refers to, etc. What projects has been used at, say, for example, that your organization keeps trace of all the projects that it was involved with and the tools that it used. You can get back all these triples. And then you put together all the triples from the, say, 10 relevant entities that you got back as relevant, and then you might reorder them. So as some of you might know, in In RAG, you have things like document compressions, Colbert, and other tools where you can make a second step of reordering of the RAG documents to get the best. And then finally, once you have the whole prompt, you send it to the LLM, and hopefully you should get an answer that, in this case, we expect to be better than what it would be with a document-only RAG, because the triples should contain, as you can see here, for example, it contains a definition of what a graph database is, which means that, for example, if a person in its CV doesn't mention graph database or doesn't mention semantics or doesn't mention GraphDB, but it does mention that it works with graph-like structures with nodes and properties, then we will know that that person has indeed worked with these technologies, maybe calling it with a different name. This is a silly example, perhaps, but you can get a better example using your own example in your own domain. Going a bit forward, so we didn't do a statistical study because we are not claiming here to have solved anything, but from the small exercise that we did, the answers that we got back, the selections of people that we got back were very, very close to what any of our principal consultants would have done with the same situation. So this was very interesting and enticing for us to discover. So what have we learned in the end? We think, like many others, that graphs are good companions to RAG. And why is that? We think that is because they are very easy to query and navigate. For example, you can do a multi-hop query. This query here was one hop, but you can imagine to extend the query to be multi-hop. And also, here I was getting back all the relationships between all the nodes because I didn't have a particular relation that was more important than others. But if you do have one that is more important than others, for example, if you are only working with skills and mandatory skills for doing a certain project, you can follow only that relation in the graph. And by doing that, you have less triples, but more relevant in your result set that you get back. And you can provide an LLM with a smaller prompt, but more relevant prompt. That is usually better because, as you know, long prompts tend to create hallucinations. So implicit links are surfaced. And also these triples, unlike documents, they are very atomic, very clean facts. They are very small and they tell the truth because they come from your curated knowledge base, from your graph. So this is why we think that it makes sense, even just conceptually, that graphs are indeed a good idea to use in RAG together with more unstructured documents. And the other point is that we think it's good to use LLMs as interfaces. And by that, I mean that we shouldn't see LLMs as much as databases containing knowledge, because we already have knowledge most of the time in curated places where we know that we have put our knowledge and that it's real and verified. But LLMs are incredible as natural language interfaces because they explain things in a very natural way. So you can expose the same information to different kinds of people, to non-technical people, or you can help technical people to fill the gaps between all the various bits of information that they have. However, setups are extremely fragile and brittle. This is probably common knowledge for many of us. These things, you change a comma somewhere, you change a small parameter, and the results can be dramatically different. So this is why it's important not to fall into the trap of the magic bullet solving everything. But if you have in your own domain, in your own organization, if you have a confined task, try to approach it with these methods in a sort of artisanal way, at least as a first attempt. And then maybe you can try to scale it up, but it's very important to keep this in mind. These approaches are brittle in their essence. And again, we haven't solved open problems, but we learned how to compose features, how to compose micro features, And we already have a number of other ideas in mind to try and apply with our clients. And we also opened up our notion of semantics, because I think one important thing in our sector is not to be too dogmatic when we talk about what a graph database is or is not, and what semantics is and is not. Where does syntax end and semantic begins? It's very hard to tell. Where does sub-symbolic AI ends and symbolic AI means? One thing that I learned through this exercise was to make all these borders more fuzzy than they were before, and I'm very happy for that. And thank you for the attention, and I'm open to any question or consideration. Thanks.
Thank you for that presentation, Matteo. We're open to questions. I'd like to just compare the representation of RAG versus GraphRag. The added benefit is contextualized bits, right? Like you can look at the synonyms and build and connect those implicit relationships. One word may be represented by different, or one concept may be represented by different words. Whether I use Word documents, or I know Google Office, or I know Google Docs, they all sort of mean I can work with some rich text formatting interface, right?
Yeah, exactly. And I think in our case, where we were trying to match relevant people to the skills or to the projects or vendors, etc., the important bit there is that in the triples, in the facts, you might have connections between apparently distant, things that for the LLM would be distant, but actually they are very close in your own specific domain. Because these examples were already quite niche, but you can imagine that in other sectors, the level of niche of these concepts can be quite high. And so in all those cases, it can be important to have definitions, alternative labels, implicit links between things. Obviously, an RDF triple store is able to fill the gaps of implicit knowledge from the explicit one, because it has reasoning, even if it's very lightweight most of the time. But for example, you might have a transitive closure closing all the hops of a long hierarchy and presenting you with all the parents or all the children of a given concept, and you can provide that to the LLM so that it has more power to it. Obviously, it depends on what model we're talking about, because on one side, we said we wanted to democratize using small models, and this is absolutely true. But if you have a bigger one, it will be much more capable of doing more complicated inferences. And so if you have triples plus good inference, then you really open the door to potentially something interesting. But again, we are not claiming we tried something that looked very interesting to us. It opened up a portion of this world that we were less open to before. And I think if more people do it, it will be beneficial to everybody.
So let me ask you this. You worked with you worked with this proof of concept, very small scale use case and defined parameters. How do you see this methodology being played out if you were to create a graph rag with existing knowledge graphs?
I think vector search is the key there. So let's call it normal vector search, is always the first step. As we have seen in the RAG architecture, you have RAG over the graph, RAG over the documents, but they all start with the same thing. That is, you perform a vector search first, and the better that is, the more relevant things you get back from the graph or from the documents, and the better position you are in. So even if your scale is massive, but if you do a very good vector search and you intercept the most relevant entities from billions of entities in the graph, then you have a smaller graph with only your relevant entities, and you can explore their relationships and their attributes, because at that point you will have a relatively small amount to talk. So the message I would give here is let's not downplay the role of normal, more traditional things, because things like filtering out the noise, and performing a very good search first will open the door for you to these more advanced things, because without that you will encounter the problems of scalability that you mentioned. One thing that I haven't talked about are agents, because there's no space to do it here. I haven't used much agents because with small models, I think they still perform quite badly, or maybe it was just my incompetence with it. I don't know, it could be both. But that's maybe next year we will be here talking about agents a bit more. But I think for the moment, I will still stick to I would call it perhaps non-autonomous forms of AI for these kinds of applications.
Yeah, no, I'm glad that you brought up that the core principles of organizing and structuring data and knowledge is a underpinning requirement to do non brittle use cases. I mean, it just reinforces the point that Bilal made, that you reach a certain point within a use case that you need to extend some sort of taxonomy or categorization structure to make sure that you're looking in the right vertical of information and not sort of just doing these
absolutely
word clouds.
Absolutely, and many people nowadays talk about the fact that we have to go back to the principle of data quality even more than before, precisely because we are starting to have these tools that can potentially mess up everything, and
there's more power to it.
Yeah, and because these things work a bit like having a semantic bucket where everything goes in there, and then it gets smashed into a vector space, and it's very difficult to understand what's going on in there. So it's more important to go back to data quality in your organization, and to have dedicated people thinking about these things, how to structure things, information architecture. All these things that we've always been passionate about but weren't so popular in the last years. I think now they are getting back with vengeance.
Yeah, no, that makes perfect sense. People should be benchmarking and monitoring the quality and the performance of these searches. How close is it to the intent of the user to get the information they require? And then how do they fine tune that, right? Like, what other additional structures do they need to bake into that schema to make it closer to the intent?
Oh yeah. So I mean, in graphs, sometimes you might add a simple class or relation, which makes you inherit a lot of information from the parents or children of that node, and you might get a lot of things for free. And this is why you need, I think, dedicated people to look after these things without becoming obsessed by it, without becoming dogmatic, of course, because now with AI we can, for example, as I said, summarize things or guess the meaning of a column on an Excel file, which was very hard to do before. So I am open to the sort of fuzzy and scruffy AI, to use a term that I think belongs to Mark from the 60s or 70s. I made peace with scruffy AI way more than I used to have when I was studying, when I was very symbolic and very oriented towards neat models and all of that. So I think we need to find the sweet spots between the two things, being neat but not closed. There's always space to maybe add a scruffy arrow or a scruffy ball on your blackboard and see what happens. But still, you have to have the people in the loop to monitor the situation and the data quality.
Aren't we as humans, as primal animals, scruffy in ourselves?
I mean, when I look at this table, the first thing I see is still a gray pattern of things with some legs, and then at the moment I associated with, maybe it's an office, maybe it's a room, and maybe it needs chairs and all of that. So we need to find that sweet spot to build, and this is the challenge of neurosymbolic AI. I think we will see finally in our lifetime if we will manage to close the gap somewhat between sub-symbolic and symbolic AI. It will be fascinating to see.
Well, and then we're going to take a... Well, thank you first, thank you.
Thank
for
you.
The presentation. I just want to say that we're going to take a break. Grab a sandwich, grab dinner, whatever you want. After we come back, we're going to be with Garima, and she's going to talk about the results of her experimentation with developing ontologies using LLMs. So that might be a compliment to this one.
Yeah, absolutely. Looking forward.
So we'll see you guys soon in about 30 minutes or so. Bye.
Thanks, Joaquin. Bye.